I smell you hobbits as you come back to Pocket Ronnie.
Okay, we're going to use this idea of conjugates into solving. So the instructions on 8E, 7, and 8 say they want you to find the factors and then they want you to solve. You can see this is going to have two solutions. Okay, let me show you before I work this one out, going back on if they told you you had x squared minus 16 and they said to factor. Okay, if this was set equal to 0 and they wanted you to factor. You notice that this is a difference of two squares. They're a perfect square. Difference of two squares always factor out into conjugates. X plus 4, x minus 4. How did we get those factors? We took the square root of x squared, which is x, and then we took the square root of 16, which is 4. One was a plus and one was a minus. Then you can continue, then you set each parentheses equal to 0 to solve. We're going to do the same thing up here, difference of two squares. What is different is that ours now are not perfect squares, but you still take the square root. In order to get our factors, you're still going to factor, and they will be conjugates. So you know one's going to be a plus and one's going to be a minus. They're going to look exactly the same except one's a plus, one's a minus. Take the square root of 5x squared to get your factors. So square root of 5x squared and then square root of 10. Same over here. Square root of 5x squared, square root of 10. That's how you get your factors. Now, we can't do the square root of 5, but we can do the square root of x squared. Square root of x squared is just x. So we can pull that out as an x and then leave the square root of 5. And then we can't do square root of 10 anymore, so leave it just like that. Same here. Square root of x squared is x, and then we don't do square root of 5 and then leave square root of 10. We can't simplify these radicals anymore. So now that we've got this factored, now we set each parentheses equal to 0. So now set x square root of 5 plus square root of 10 equal to 0. X square root of 5 minus 10 equal to 0. Okay? Now, back when we had x minus 4, x plus 4, and we set each equal to 0, could you see that they were going to be the same solution except one was a positive and one was a negative? Okay, so square root of 10 goes there. Okay, when back with our example of x minus 4, x plus 4, and we solved it, one was going to be a positive 4, one was a negative 4. They were the same solutions except one was a positive, one was a negative. The same is true here. When you have conjugates and you're solving, your solutions will be the same except one's a positive, one's a negative. To prove this, let's just go solve for here because I'm solving for x, which means I want x on one side and everything else on the other side, which means I'm going to subtract square root of 10 to both sides. That cancels. So I have x square root of 5 equals negative square root of 10. How do I get rid of my square root of 5? Divide it away. Divide both sides by square root of 5. That cancels. You can either go through the process of getting rid of the radicals in the denominator or the rules of radicals. You can divide radicals to radicals. So negative square root of 10 divided by square root of 5 is a negative square root of 2. So x equals negative square root of 2. Now going back here to this solution, right here, x square root of 5 minus square root of 10 equals 0. Add our square root of 10 to both sides. That cancels, so I'm left with x square root of 5 equals square root of 10. How do I get rid of this? Divide it away. That goes away. Square root of 10 divided by square root of 5 is a positive square root of 2. Do you see our solutions are the same except one's a positive, one's a negative? You can just write it like this. Let me write it here in the middle with a different color. You can write it as x equals plus or minus square root of 2. This means one's a positive square root of 2, one's a negative square root of 2. When your solutions are the same, this is how you can write it. This means plus or minus square root of 2. Okay, now let's look at 8D, 7 and 8. Same kind of problem. We are using the idea of conjugates to solve the problem. When you see two terms in a subtraction sign, you should always think of difference of two squares. Okay? Difference of two squares factors into two parentheses. You know, one's a plus, one's a minus. They are conjugates of each other. How do you get these terms? You take the square root of each one of these. So I want the square root of 7y squared, the square root of 9. Same here, square root of 7y squared and square root of 9. So I can do the square root of y squared, but not 7. So the square root of y squared is just y, and then you leave the square root of 7. Square root of 9 is 3. So now you should know our second parentheses is going to look exactly the same except a minus sign. Now we set each parentheses equal to 0. So we have y square root of 7 plus 3 equal to 0, and y square root of 7 minus 3 equal to 0. Now let's solve this one. Subtract 3 from both sides, so you get y square root of 7 equals negative 3. I'm solving for y, so I got to get rid of the square root of 7 by dividing it away. That goes away. Y equals negative 3 over square root of 7. Can I leave my radical in the denominator? No. How do I get rid of it? When it's just a radical by itself, you can multiply it by just itself, square root of 7. Therefore, I have to do that to the numerator. So this becomes negative 3 square root of 7. Square root of 7 times square root of 7 is square root of 49, and square root of 49 is just 7. I can't reduce any of my whole numbers, so I'll leave it just like that. Now, do you want to go through the whole process of solving this? No. Don't make it harder on yourself. We said that when you have the conjugates, your solutions will come out the same, except one is a positive, one's a negative. We already have the negative here, so we know that the other one will be a positive 3 square root of 7 over 7. An easier way to write it is y equals plus or minus 3 square root of 7 over 7. Writing it this way is just the same thing as writing it 2 different times with a negative and one with a positive. Here you just write plus or minus. So one is a positive solution, one is the negative solution.